My guest today is David Siegel.
I'm going to ask you to get a pen and paper. So take a second, stop the video if you have to. Go, I want you to continue with a pen and paper and do the exercises as I present them, because you're not going to be able to do them later. These exercises are based on a series of research papers conducted by Dan Cahan at George Washington University. And it has a lot to do with how we understand the world around us. In this study, researchers made up a fictitious experiment where they gave a new kind of cream to people who all had the same kind of rash. So next, I'm going to show you the results of the study. And I'm going to give you 30 seconds to decide whether the skin cream helped or didn't help. Don't pause the video for extra time. 30 seconds is enough. All right? Here's the numbers. In 30 seconds, which do you think worked better, the cream or no cream? Write down your answer. And Tom, if you want to come up with a guess, that's fine. If not, that's fine. Sure. So this is all about statistical numeracy. Give people 15 more seconds. 30 seconds is kind of enough time to be able to rationalize at least a first order guess. All right. So now let's find out what's going on here. Keep in mind the numbers are just made up. Most people just look at which numbers are larger, but you have to look at the ratios. Doing the math, you can see that without the skin cream, 5 times more people got better than got worse. And with the cream, only 3 times more people improved. So without the cream was better than with the cream. And this is the difference between System 1 and System 2 thinking. System 2 takes a bit more time and effort and is often the opposite of your initial reaction. All right, so the results showed that those who had higher numeracy skills got more right answers. They were more used to working with numbers. All right, so that makes sense, right? So now I'm going to show 2 more sets of numbers. And these are about gun control. Again, this is a fictitious study where they took cities without gun control and cities that enacted gun control laws, and they looked at the homicide rate over the following decade. And we'll look at the United States and then Australia. Take 30 seconds to determine which was more effective, with gun control or without gun control. Here we go. This is for the United States. You have 30 seconds. Write down whether you think gun control worked or gun control didn't work. Got to make sure and give people the full 30 seconds. All right, now I'm going to show you the data for Australia. Again, you have 30 seconds. Write down whether you think gun control worked or gun control didn't work in Australia. All right, let's see what's going on here. It turned out that the researchers weren't testing numeracy at all. They were looking at how politics affects our ability to understand data. So let's see what they learned. Remember, these numbers are just made up. They have nothing to do with actual crime rates. In the first one, you could have figured out that even though the numbers are larger, the ratios tell a different story. According to this data, cities in the US with handgun laws saw crime increase 5 times over 10 years, whereas cities with no gun control saw an increase of only 3 times. So according to this data, gun control works. Next, according to this data from Australia, in cities that had no gun control, crime decreased by 4 times, whereas cities with gun control, crime decreased by only 2.3 times. So in this case, gun control is worse than no gun control. Gun control was better. No gun control in this case was better. So if you're a rational person, your answer sheet should look like this. Gun control made cities safer in the United States, and no gun control made cities safer in Australia. But your answer sheet may not look like this, and this is how it breaks down. Not all countries have conservative versus liberal politics, but for the purposes of this exercise, you should be able to see where you are based on your answers. So here, a rational person would be able to do the math and find that gun control made cities safer in the US and not in Australia. A liberal person is just going to say gun control is always better and find a way to justify that. And a conservative person is always going to try to justify no gun control being better in all cases. And then someone who just can't figure it out probably may have gotten it all wrong. The researchers team found out that the smarter people were, the more numerate and science literate they were, the worse they were at determining the effect of gun control. When the data agrees with your worldview, you do the math and you find the signal. But when it doesn't, you challenge the data or find some way to justify the opposite conclusion. These people use motivated reasoning. The researchers did this for climate change, nuclear power, abortion, and other politically charged topics. And they found the same thing every time. More scientifically and statistically literate people were unable to detect the signal if they disagreed with it. And the interesting thing in the case of gun control, climate, etc., was why? Because the real risk isn't about doing the right thing or helping humanity. The real risk is about people's individual well-being. And here's what they say. Given how much the ordinary individual depends on peers for support, material and emotional, and I would add especially their salary, and how little impact his beliefs have on the physical environment, he would likely be best off if he formed risk perceptions that minimized any danger of estrangement from his community. So it's more about estrangement and staying a member of your tribe than it is about understanding the world. And this is my way to frame it. So this may help people see what's going on. The first thing to understand is that different issues are personal for each person. Can you see my little cursor running around?
Yes, I can see it. Yep.
Yeah. So the actual issues here are just for each person. You'd have to put in your own. So what's important here is the framework. And so here's another one where I've changed the issues. I'm showing the framework to help break down where the sticking points are. And so if it's personal and you can see it every day, you're more likely to be motivated to speak out against the status quo, especially if it's frustrating or you're going against you. On the other hand, if it doesn't affect you personally, you may have a strong incentive to agree with the people you see and interact with every day. This is why it can be so toxic to talk about certain subjects at work. It's why everyone has an opinion on what's the best diet, but nobody looks at the research, and most of the people with the strong opinions are overweight. So because people identify with their group and want to stay in it, they don't want to talk about the science. They believe what they hear from people who are like them. I've asked, and you probably asked, hundreds of people, why do you believe CO2 is warming the planet? The answer is always the same, because it's obvious. They have no interest in understanding the underlying science or trying to find mechanisms or seeing how complex it is. That includes anyone in charge of climate policy or climate investing. They don't have time to learn. They're too busy saving the world. So here's an example of motivated reasoning that I'm sure you've seen. In February, I saw this post and reposted it on X. Now, the picture's real, but it says that Krasnoyarsk has had a temperature of minus 73 degrees Celsius. Within a few days, I had 300 more followers than I had before. Everybody loves this image, but I started to wonder about that 73 degree number. That's it. So it's like minus 100 degrees Fahrenheit. So I learned that Krasnoyarsk does get down into the minus 60s, which is very cold. But the minus 73 degree claim was just made up. So I posted, and you may not have noticed this on X, I posted several times, I was wrong. I was wrong about this minus 73, and I was looking for more accurate data Does anybody have any more accurate data? But no, everybody's too busy reposting the stupid thing. So it gets halfway around the world before the truth can put its own pants on. Nobody is fact checking things they want to believe. And we all do this. Everybody does this. Okay. So there's an example from the world of medicine that particularly is a bee in my bonnet, and I want to explain it. It actually may have some help for people and for people's parents. The FIT2 trial of a drug called alendronate to prevent bone fractures in older people found that the drug cut fractures from 43 out of about 2,000 down to 19 out of 1,706. Now, this is kind of like what we've just been looking at, right? And that is indeed a 50% relative risk reduction. But the absolute risk is only 1%. And the drug has huge side effects. These drugs, like Fosamax and Boniva, are billion-dollar products that are prescribed thousands of times every day by doctors telling patients that they reduce risk by 50%. Your parents may be taking these drugs now. They make billions and billions of dollars, but they don't help patients. Here's a Google search. Look, Google, Grok, ChatGPT, and a medical help website. They all say, look at it, reduce the risk of fractures by 50%. They all say that. The actual numbers are tiny, barely significant, and the downsides are huge. Drug companies use SEO, search engine optimization, to convince the bots that their talking points represent science. So patients think, wow, this drug really works. And doctors who aren't statistically literate pass this information on to their patients. Most doctors are not statistically literate. So the drug companies have what I call narrative supremacy. And they aren't going to do anything to change it. They love how the AIs and the search engines are positioning their products right now. If you know anyone on these drugs, tell them to get a better doctor. All right, so this kind of reasoning, messaging, and laziness is everywhere. To avoid being wrong, to get away from politically biased thinking and motivated reasoning, here are my suggestions. First, if it's personal, don't assume that everyone has the same problem or everyone sees it the way you do. It's personal. For example, I've met people who believe all vaccines are bad for everyone, and that is absolutely not the case. Penn Jillette, you know, Penn and Teller? Penn says, if it's something you want to believe, that's when you should question your assumptions most. I really like that. If you want to believe something, if you're not neutral, that's when your bullshit detector should start flashing red. For 45 years, I was vegan. I wanted to believe a vegan diet is optimal for humans, and I promoted it. But I was wrong. Being vegan is not optimal for any human. It's a suboptimal diet, regardless of the anecdotes you may hear. And perhaps you could put my health and longevity website into the show notes so people can, I'm blogging about this stuff all the time. It's just these are polarizing topics. Very few people want to understand the science because it's another identity issue. So I had to change my mind when I changed my diet, when I changed my mind, because I learned new data. And by the same token, if you think nuclear power is bad or humans are changing the climate, something that's invisible and affects other people, ask yourself how you know that. Most likely it's from anecdotes, stories, and repetition. It's not from actually reading scientific papers or meta studies or understanding the details and the nuances. Double check your sources. Think critically about what you're being told. If you think humans stopped the ozone hole from getting bigger by changing their hairspray and refrigerants, if you think fluoride is toxic, if you think jets are leaving chemicals in the sky, look deeper. Look past the headlines. Don't just pass on what you hear from your friends. Read the literature, especially the meta studies, with curiosity rather than conviction. So speaking of curiosity, it's time for the next paper. Recall that scientifically literate people do worse when evaluating data from politically charged topics. Kahan did later research not on scientific polarization, but on scientific curiosity, and he found something very interesting. In the US, our two main groups are liberal and conservative. While scientifically literate people of opposite political beliefs tend to diverge when they study the same data, scientifically curious people of opposite political beliefs tend to converge when studying the same data. The more curious and humble you are, the more you will converge toward the truth. This, in fact, is borne out by exercises called adversarial collaboration, which I think we should try to do much more for climate science. The reason I put the risk low here is that I've seen too much data and read too many papers, and I've never seen a single paper that shows humans are impacting the climate. To me, it's a case of not much correlation and zero causation. But hey, it could be the other way. CO2 could have a measurable effect no one has measured yet because maybe the signal is hidden in the data somewhere. So I need to be able to say what it would take to change my mind. And in fact, I have changed my mind, just as most of us have. In 1991, I wrote this book on how CO2 was heating the planet and also about how veganism was the optimal diet and overpopulation was going to destroy the earth. Okay, well, I was young and impressionable in those days. And in 2015, I took a whole year, like the big year from birding. I spent a big year looking at data and reading articles, and a lot of them were by Willie Soon, and I changed my mind. I'm always learning new things about the climate system and revising my view. If I saw enough evidence that contradicts my current beliefs, I'd have to change my mind back. So what would it take to change your mind? What would it take to falsify the idea that CO2 from humans is causing warming? Can you say? Now, you've made a movie about this, Tom, and in this next section, I will present the main, I think, about 10 pieces of evidence in favor of the thermal model of climate. If you're not familiar with my thermal model, and other people talk about the thermal model, you can find it on my video series at climatecurious.com. Here are about 10 things I would need to see falsified to believe CO2 is driving our climate. I'll run through these pretty quickly as a summary. The incoming energy from the sun is not constant. It's always changing on different timescales. It changes from year to year and decade to decade. Changes in solar activity are related to the sunspot cycle, but there's probably more to it than that. The IPCC says solar variance is negligible, but it isn't. These cycles have a huge impact on our climate. When the Bray and Eddy solar cycles combine, they cause cyclical warming and cooling periods that last a few hundred years. This shows how temperature is directly affected by solar variation on the scale of centuries and decades. This model, which you're very familiar with, shows that CO2 is a very strong greenhouse gas, up to about 50 parts per million, which the Earth has always had. Even 4 billion years ago, when it was a cloud of rocks, dust, and gas, there was more than that, 50 parts per million. There's a lot more than that, actually, because most of it is now sucked into rocks. The absorption and re-radiation by CO2 is shown in the magenta area you see here for the 50 parts per million level at the 15 micron wavelength. It's huge. It's a huge effective greenhouse gas. It's not there. You can't say it's not a greenhouse gas. It is, and it has a huge effect on temperature up to 50 parts per million. Now, if I just remove that so you can see, increasing the concentration of CO2 from 50 parts per million to 400 parts per million. Now that's the black line you see here. Well, that adds a little area under the curve, and there's a little warming to that, maybe or maybe not. We don't know, but to increase it all the way from here to 800 parts per million, and that's shown by the red line, and that would double CO2 from where we are now. Hardly changes the absorption of infrared radiation in this part of the spectrum at all, and certainly can't lead to too much temperature change. There can't be any tipping point. It's impossible, even with all this made-up feedbacks and everything else built into the models. It can't happen, and it's the same with methane, by the way. But doubling from CO2 from here would increase plant growth by at least 20%, maybe even up to 40%. From where we are today. And that's why most greenhouses run at 1,200 parts per million CO2. I maintain a list of 175 PhD scientists who agree that more CO2 would be better. And a few of them say it could also cause some warming. But in my view, and I think also in your view, Tom, more CO2 would be very beneficial and would not cause any warming at all. It's just not, it's no longer a driving factor, even though it is the first 50 parts per million. So according to the IPCC, as CO2 forces temperatures higher, more energy will accumulate in the upper atmosphere, in the troposphere, and there would be a corresponding amount of energy not radiated to space because it's building up. But here we see satellite measurements showing that both incoming and outgoing energy have increased, which is evidence that albedo has decreased. Albedo is reflectance, mostly from clouds. A small change in albedo can result in a huge change in temperature, and that's what we've been seeing for the last 20 years or so. This could easily be the driver of most of the temperature change in the last 20, 30 years. And also, that may have caused increasing trend in high altitude winds, which has changed the way heat is transported north, and some El Niños, which also may have to do with albedo, and then a completely unrelated volcanic eruption that happened just had to have a huge effect on stratospheric water vapor for a few years, absolutely out of the blue, just a one-time event. 2022 NASA paper concluded that clouds and albedo, which ultimately determine the incoming shortwave radiation of Earth, are variables of the utmost importance for current climate change, in agreement with previous research about the changes in stratocumulus or energy imbalance in the last 4 decades. I really wish people would read the peer-reviewed research. It would just help so much. Water vapor is the main greenhouse gas, and the models don't know what to do about water vapor, so they're mostly based on CO2. For more than 40 years, the models have been predicting warmer tropospheric temperatures in the tropics than we have observed. And this is supposed to be the hot spot that heats up the most. This is John Christie's graph that you've seen. The red column is the average of all the models, and the yellow line is what we have observed from measurements. Most models have consistently overpredicted this number by almost a factor of 2. Since I can't find anything in the IPCC reports or the peer-reviewed literature that overturn these observations, I have to believe that the CO2 hypothesis is false and the models are politically motivated tools. Antarctica is not warming, as you've said many times. Western Antarctica fluctuates because it's at sea level, but the Antarctic plateau has had steady temperatures for the last 30 years since we've been measuring it. CO2 is definitely rising there and temperatures are not, which invalidates the radiative model right there. But it's more interesting than that, Tom. The Antarctic plateau is huge. It's a continent. It's always below freezing, and has very few glaciers to carry excess snow into the sea. So for 3 million years, Antarctica has just been accumulating snow. It can't go anywhere else. It's sucking water out of the oceans. The South Pole Station is built on stilts because they keep having to jack it up off the snow, which keeps rising. Rather than causing sea level rise, Antarctica is constantly pulling water out of the oceans and has no chance to melt. The only way to complain about Antarctica is to go to the volcanic Western Peninsula, where water temperatures fluctuate because of volcanism, and you can look for some chance event and then report it as a signature of global warming, and that helps bring in more research money to buy more stilts for the station. The tropics are essentially insensitive to changes in CO2. This is Papua New Guinea. They all look like this. Any place with a thermometer in the tropics looks like this. Oh, except here's the Seychelles. Here's the Mahe Station in Seychelles, which has data since 1890. And look, you can see about a 1 degree rise here since before 1980. And that's from a remote weather station that they moved to the airport when they built the new airport in 1972. So the weather people could more easily record temperatures near their offices, and they didn't have to get in the Jeep and go off and read thermometers. So the story here is of stable temperatures followed by the growth of their tourism industry. That's what we're measuring here. If you look for a hockey stick rise in temperatures, you have to be very selective where you look, because most remote weather station series don't show it. CO2 only seems to drive temperature near urban areas and places where there are no weather stations, miraculously. Sea level. Here's a hockey stick showing sea level rise in American Samoa, where the UN Secretary General Antonio Guterres last year made a video saying sea level is rising fast and will soon, he said this, will soon come to all coastal areas. He specifically went to American Samoa because there was an earthquake in 2019 And since then, the whole island has been sinking at a rate of 6 inches every 10 years. Elsewhere around the world, adjusting for land movement, sea level has been rising about 8 inches every century for the last 250 years and shows no sign of acceleration. The IPCC admits in their technical chapter 9 that downwelling infrared radiation can't penetrate the ocean skin. They imagine that more CO2 heats the oceans anyway, but they've never shown that. Even basic physics textbooks explain that infrared radiation is too weak to penetrate water. The only thing that warms the oceans is direct sunlight. No amount of CO2 or water vapor can heat the oceans, and the oceans drive our climate. The tropics receive a huge amount of energy directly from the sun. Now, about 80% of all that energy entering the system at the tropics is radiated directly to space. But 20% of all the energy coming from the sun moves poleward and exits over the poles in winter. The transport of that heat drives our climate system, first through ocean heat around the equator, and then gets distributed via storms and winds headed to the poles carrying that heat, something the IPCC does not acknowledge. And we see this at the polar ice caps. There's so much nonsense about the polar ice caps. When you hear the ice is melting in the Arctic, that's heat being transported north and stored in the ocean by melting ice. It later comes out in winter as the ice refreezes back over, extending the ice by an area roughly the size of the United States each winter. It's a huge release of infrared radiation to space. Less ice in the Arctic from one year to the next is a direct response to low solar activity, which causes a weaker vortex, allowing more heat exchange from the temperate zones to the poles. This is how you get cold winters in Florida and warm temperatures in Alaska, even in January. It's a natural cycle that has been happening for millions of years, at least 3 million years. It does not have anything to do with CO2. It's not a radiative effect. It's the sun and clouds modulating heat transport in the troposphere and stratosphere. Nothing is linear, cycles fluctuate, and it's easy to be fooled by randomness and natural variation. So this leads to one of my most important lessons, Tom, which is that overall, across a wide variety of topics, skeptics have a better track record than promoters. If you think of all the past scares of eugenics, acid rain, ALAR, ozone hole, Y2K, methane, mass extinctions, pesticides, meteor impact, AI takeover, ocean plastics, there's so many. The press loves to promote the possibility of catastrophe, but you can bet consistently against those catastrophic prophecies and come out far ahead. The two main threats I worry about are government overreach and the fast rise of stupidity as a result of a collapse in birth rates. Those are my top two. The precautionary principle never applies. It says you must do everything to prevent something bad happening, even if it only has a tiny chance of happening. That would squander our resources on wild goose chases. If the assumptions are wrong, the solution won't work. Governments usually cause more disasters than they prevent. Free markets allocate resources most efficiently. Richard Feynman said, first, you must not fool yourself, and you are the easiest one to fool. So the question you should ask yourself is, if you learn new data that didn't support your beliefs, would you change your mind? Would you tell your friends? Or would that be too risky in the group of people you live and work with? If you can't say what it would take to change your mind, then you're not scientifically curious. Al Gore's film used this image, which shows a northern hemisphere hurricane turning the wrong way. It wasn't an accident, and it wasn't about the southern hemisphere. Now, I don't know for sure, but I know designers. I am a designer. They'll gladly flip an image to get the right look. So I believe it was because if they showed the hurricane going the right way, it would look too much like a question mark, which would lessen Gore's perceived authority. So I think they looked at it both ways and decided this was the way to go. Accuracy did not matter because it wasn't a work of scientific integrity. It was propaganda, and it worked very well. They flipped a lot of charts in that movie. I could make a movie about that. Feynman said, I'd rather have questions that can't be answered than answers that can't be questioned. But in climate science, there are too many unanswered questions and too many unquestioned answers. Today, only one university president in the United States is willing to question the assumption that humans are changing the climate. One. The rest can't say anything or they'll be fired. At UC San Diego, I sent you a note about this. Every student is required to take their climate course to graduate. It's a requirement. In today's political climate, I still don't see enough scientifically curious interaction between liberals and conservatives. It's not happening. I hope we can all ask ourselves hard questions and have uncomfortable conversations, and maybe even a serious debate that I've been proposing for years. Now, you've had a few debates with people I think are very instructive. There have been a couple of debates, but they haven't really moved the needle that much. And I want to take this up to the next level and talk about my debate. So if we're going to continue to spend trillions of dollars on climate solutions and handing our industrial economy to China, we should maybe spend a few $1 million on a debate I hope will be highly influential. The idea is to hold a 2-week event and bring both sides together to present their case in front of a panel that would be sort of like a Supreme Court hearing. I want to break that down, if that's okay. So I'm going to start with a small staff of 3 people and 2 neutral moderators, people interested in science who are well known to the press, like there's Russ Roberts, Destin Sandlin, Derek Mueller, Grant Sanderson, Rebecca Smethurst, Vanessa Hill. There's a bunch of good people who could be the 2 neutral monitors. Then we're going to recruit a panel of 13 qualified experts in statistics, data science, meta-analysis, decision theory, science communication, history of science, paleogeography, chemistry, physics, etc. 13 people. These people may already have a bias, but they should be able to say what it would take to change their minds. They should be neutral enough. So I think we can find those people. Then we get journalists from big magazines, and these magazines commit to running a big issue on climate science all at the same time after the event. For the 2 weeks, all the media would be embargoed and everything would be kept quiet. We would hold the event at a secluded location where we would rent out a small resort and just take it over for 2 weeks. Finally, we have the pro and con team leaders and their teams. 2 team leaders would be chosen for each side, and they would organize the arguments and the presentations. Here's how the money would work. The full-time staff would be paid for 6 months leading up to the event and 6 to 12 months after. They would hire a PR team to help get the magazines and journalists on board. In reality, only a few of these magazines will commit, and only if they are paid to dedicate a full issue to the topic. We know how magazines work. But they would also hire an audiovisual and logistics people to coordinate everything. The experts will all get a stipend for the panel of experts. The team leaders would get a small budget to spend however they like, but most of the team members won't be paid, but the winning team will split a prize of, let's say $2 million. They can use it however they want. And this is only about climate science, not energy, because the two are not related. It is also not about the implications or mitigating of rising temperatures, nor is it about economics or politics. Just science. The moderators will set the rules, the schedule, and run the event. The 2 teams talk only to the panel of experts, just like in the Supreme Court, presenting their evidence in turns as in a jury trial. Sessions last about 2 hours. Most experts will present via video, not in person, kind of like giving a presentation to the Tom Nelson channel. Moderators and experts can ask questions. Each team has time for rebuttals. During this time, journalists may film, interview, and write what they like, but all the media are embargoed until the final Sunday evening. So as you can see, this first week lays down the basics. Second week builds on the first with systems and model projections. Each side argues its case, provides documentation. The other side is allowed to respond. Moderators guide the process, and the panelists are encouraged to ask questions. It's their job to understand as much of this as they can, and AI is not allowed because they're going to render their judgment at the end. Thursday, the final Thursday is a catch-up day where moderators and panels can bring anything back to re-examine. Friday, both sides make their closing arguments. The goal is to have a lot of social interaction among the participants, fostering a sense of learning together and collaboration. There might be some exercises to help people find common ground. We'll bring in some special guests for that evening event. Now, the last 2 days. Saturday is a day of media interviews. The panel members and moderators will be sequestered individually to write their conclusions by themselves which are due by 3 p.m. Then the press must leave. The panelists and moderators will cast their 15 votes, and they will elect majority-minority opinion writers who will work through the night on their opinions. Neither side knows how the vote turned out. Big banquet dinner for everybody else and more special guests. Overnight, their opinions are collated, and the whole thing is made into a book that is printed on site. The majority and minority opinions are added at the last minute. Sunday, the press is invited back at noon. Panel members and moderators present their findings to the press, the winning side and the vote, how the vote turns out. There's 15 people, so there's probably a winner. The winning side is announced and awarded the prize. Books are handed out. Website is published with all the videos and supporting documents. This event is covered in the media, and all media are free to launch anything and their big issues during the next several days. Now, there are two big problems, of course, and I think they're solvable. First, I need a budget of around $20 million to make everything work, provide the incentives and get the word out, mostly for incentives. That's a drop in the bucket compared to what most liberal billionaires are splashing at fake signaling and solutions, not to mention government-funded conferences alone. But still, it has to come from somewhere. I'd like to see Warren Buffett. Maybe you're going to go see Warren next week, so ask him if he can, just 20 million. I'm not asking, just $20 million. Not, it's nothing. Maybe Bill Ackman, Peter Thiel, somebody they could combine their money. It's not that much money. But then the big problem is the mainstream climate people won't be interested to come, as we know, because they have narrative control now. They can use the Trump administration as the bad guys to raise more money, and they're doing so right now. It certainly isn't in their interest to show up. But the more momentum we can build, the worse they will look if they don't participate. And I think we can find clever ways to wrestle them to the table. This book, have you read this book, Tom? Do you know this book?
I do not know that book. No.
Okay, so it kind of seems like you do because you started with Malin on points of common agreement, which is what he talks about. So this book, I think it has a 7-step method for changing minds. It's written by a true climate believer. It's absolutely the best resource for understanding how to talk with people you don't agree with. And I would love to have the author as a panelist for the debate because I'm sure he would be open a little bit to seeing new data. So there are examples of how to do it right. And I think we're not taking advantage of that enough. This book is really inspiring to me. So I'd like to hear from anyone who might be able to help me raise the money. It might take a year, whatever. I'm willing to put together a detailed budget, business plan, whatever we need. I've got kind of half of that already. And I think the event would give more bang for the buck than anything else. It would be worldwide news. If it goes well, there are several, and I don't know how it's going to turn out. I'm not here to rig the vote. Whatever those people figure, I'm just here to set it up and let it roll. So if it goes well, there are many more debates that we could hold to help investors, policymakers, and the general public understand difficult political issues rather than hammering back and forth in the press the way we do it now. Energy is too important, especially for poor people, to be caught up in a battle where basic science takes a back seat to politics. Being scientifically literate and curious is how we move forward in understanding and solving hard problems together. The debate I propose should lead us much closer to the truth and to maybe a real consensus on climate. I might even have to correct some of my views, and I'd love to do that because I want to go where the data takes me, the way Richard Feynman did. So come to my website and learn more climate science.
Yeah, that whole debate thing, you've really put a lot of thought into it. I'm impressed.
I think it's necessary. You can't rely on the way things are going now and the presidential, what are they called, orders, the executive orders, that we've got to change the zeitgeist. We've got to move the needle for the average person and for people who are fundraising hard right now. The backlash is building up, I'm afraid.
And have you seen that actual debate they had? Maybe it was 2007 with Crichton and Gavin Schmidt, and that was a good one. So long ago.
Crichton is amazing.
Yeah, he was fantastic.
Right. I wish we hadn't lost him so soon. He was unbelievable.
But don't you think that kind of was a watershed where the Gavin Schmitts of the world don't ever want to do a debate again?
Yes.
Yeah.
Yes. So but I think we have to find clever ways to pressure them into doing it.
Yeah.
Those people exist. I know that they will not say yes at the first shot, but I think we put a team together, especially a PR team, and we start a campaign to get them to they might even be right. I mean, let's listen to them. They don't, obviously they don't want that.
I like that idea. You might use this, stamp this out, and then tackle other debates on other issues. That would be fantastic if we could have 10 of these.
Renewable energy.
Yeah, medical stuff, all sorts of
medical virus origins. Yes. No, but it has to be really big. It has to be also carefully, methodically, slow and careful, and not just fast in the heat of the moment.
Is there any other precedents other than the thing I mentioned? Have they had anything where they bring the two sides together for a week somewhere and talk stuff over?
Not in this serious way. There's Steve Koonin, of course, but they rarely, it's just this wide-ranging, conversation that never really brings the science down. Not that I know of. And I think it's really, if I could start my own YouTube channel, and maybe you can give me some advice at some point, I would have a debate channel. I would have people of opposite sides coming on and talking. Anybody wants to work on that with me, I'd love to just do it as a grassroots, let's for about all topics. Let's get people of opposite sides to have reasonable conversations.
It does look like there's a few debate sites that are set up for like high schoolers and stuff. I saw one that was just set up for big text-based debates. I don't know anything else about it. I don't know who else has really dug into this, but yeah.
There's the Oxford debates are famous.
Yeah. Okay.
In an Oxford debate, it's a one evening, usually an hour and a half long. You can see them on YouTube. And the audience votes at the end, whether they vote at the beginning and then they vote at the end, whether they change their minds. But the problem is it's kind of debate theater. It's whoever's the best rhetorician. You get really strong, good people, and they, Peter Hitchens, it's going to be impossible to go up against Peter Hitchens. I don't care which side of the debate he takes. Right? He's going to crush you. Right. So these kind of theater things are not what I'm looking for. I'm really looking for science, like how to do it right, because we know how the IPCC does it, and that is not the right way. It's a lot about perception, right? Perception versus reality, doors of perception. Yeah. I think we too easily sweep things under the rug that we're not noticing. And a really important book for me that woke me up a lot was Thinking Fast and Slow by Danny Kahneman. Just how we have all these built-in biases that are running all day long. And it's very hard to stop, get off that train and just look objectively. So yeah, I think this is all operational, and I think not much will change unless we can find a way to break through these exact things. That's why, I've talked to you about climate science, and more I talk about politics and conversations and how people think and how to change minds. Because whenever you see anything online or some event or some paper, Grok GPT authors a new paper about climate science, it just doesn't change any minds.
Right. Not
at all, not one. So how do we do that?
So which billionaire would be most likely to fund something like this? Because how about Musk? Is he both sides of the argument guy? I wonder.
No, because it's going to go against his best interest. One of his arguments for going to Mars is that we're trashing the planet. He believes that at, 1,200 parts per million, you get headaches and a bunch of random stuff. So he's not the guy. I would love Bill Ackman. He's very sharp. There are a bunch of hedge fund billionaire types. Unfortunately, you've got the guys like John Doerr, who gave $1 billion to Stanford. And now nobody at Stanford can question the authority of the IPCC and the climate narrative, because that's where the money is coming from. Right? It's really, Stanford is like this hermetically sealed, and many universities are environments where you can't ask. And that's what I love about Chris Martz, right? He's just asking questions. He's just looking at data. He's like, show me where I'm wrong. You can't do that at Stanford. You cannot do that at Stanford because a billionaire gave him $1 billion, and that built a fantastic building. And Paul Ehrlich is getting paid very well to sit in some office there and make more doomsday predictions that never come true.
So two things here. Have you seen the video of John Doerr? It's from 15 years ago or more, where he's speaking and he starts kind of breaking down because he thinks CO2 is going to do something bad to his daughter. That was very embarrassing. And this other thing, Elon Musk, have you seen this from 2015? I'm looking at it right now. He claimed that 97% of scientists believe that trace CO2 might cause more displacement and destruction than all wars in history combined. That was his view on climate change.
So he's changed a little bit.
He's changed a lot, yeah.
But he still needs it to run the modus operandi of his companies, to motivate investing in his companies. Now, he's got some other issues at the moment,
Right.
but he's not going to add fuel to the fire by saying, you know what, this doesn't look good at all. Why don't we just fund a debate? But plenty of people have the money, and look at the money. We're outgunned, what, 1,000 to 1 at least.
Yes. Yeah.
Right? Maybe 1,000,000 to 1 in dollar terms.
It's a lot.
Right? But the science is on our side, and certainly the peer-reviewed literature is on our side.
Absolutely. Okay, anything else before we finish up?
No, thank you. It's just been a tremendous pleasure to get to know you and to interact with you over the years. And I hope you just keep going and keep making progress.
All right. Thanks a lot, David Siegel. I really appreciate what you're doing. Talk to you next time.
Thanks, Tom.